Okay, we're going to look at our second lesson now for test one, factoring with greatest common factors and by grouping. So factoring is the reverse process of multiplying, which we learned on Monday. It is the process of writing a polynomial as a product. To factor a polynomial, we first factor out the GCF, or the greatest common factor, if possible. Sometimes there won't be a GCF other than one. If that's true, we can go straight to working on the factoring. The strategy that we're going to use for identifying the GCF is we're going to look at finding the GCF of the different components. So first we'll look at the numerical coefficients and find the GCF of those. Then we'll look at any variable factors and find the GCF of those. And to determine the GCF, we will multiply the numerical coefficient and variable factor GCFs that we had. So first, let's remind ourselves what the GCF is. And the GCF, or the greatest common factor, is the largest common factor that divides evenly into all of the numbers that we're looking at. So let's look at just an easy numerical example first. If I wanted to know what the GCF is for the numbers 4 and 16, your first thought might be, since it's called the greatest common factor, to say that 16 is the GCF since it's the biggest number. But you'll find that a lot of times the GCF is the opposite of what the name makes it sound like. Most of the time it's the smaller number, and when we're dealing with variables to exponential powers, we're going to choose the smallest exponent as well. The reason for that comes in this part where it says it's the largest common factor that divides evenly into all of the numbers. So 16 is evenly divisible by 4, but 4 is not evenly divisible by 16. So the smaller number, the 4, is the GCF. So let's look at a couple of examples. First, if I ask you to find the GCF of 9x squared and 3x cubed, then following the strategy, we will first look to determine the GCF of the numerical coefficients, which are 9 and 3. And just like the example we just looked at with 4 and 16, the GCF here, since these numbers are multiples, is going to be the smaller of the two numbers. And for the same reason as above, 9 is evenly divisible by 3, but 3 is not evenly divisible by 9. Then we're going to look at the variable factors. We only have one variable in these two terms, and that variable is x. And we have x squared and we have x cubed. Anytime you are dealing with variable factors, if you're looking for the GCF, we are always going to choose the variable with the smallest exponent. So the GCF of these two is going to be the x squared. So if I ask you what the GCF of those two monomials, 9x squared and 3x cubed, are, then it's going to be 3x squared. So we just multiplied the GCF of the numerical coefficients, which was 3, times the GCF of the variable factors, which was x squared. So now if we look at the problem 1b, you notice I've got those same two monomials, 9x squared plus 3x cubed. So in order to factor this, you can think of looking at it as undistributing. We want a common factor that we can take out to the front, and we've already determined that the greatest common factor of those two terms is 3x squared. So I'm going to write my GCF, and then what we're going to need to do is determine what we would need to multiply times that GCF to get the terms 9x squared plus 3x cubed back. So there's a couple of ways that you can approach this. One is to look at it as multiplication, where you ask yourself, what would I have to multiply times the 3x squared to get 9x squared? So 3, we would have to multiply by 3 to get 9. If I have x squared and I'm trying to get x squared, then we don't need any more x's. For the second term, I have 3x squared. I'm trying to get 3x cubed. Well, we already have the 3, but I only have x squared. If I need x cubed, then I would have to multiply by x to the first, because remember, when we multiply like bases, we add the exponents. So x squared times x to the first would be x cubed. And of course, you can verify this for yourself. If I distribute what I just factored, 3x squared times 3 does give me 9x squared, and 3x squared times x gives me 3x cubed. So you can see that this is the correct factorization, because if I distribute it back out, we get back where we started. The second way you can look at it is as a division. So if we know that the GCF is 3x squared, you can determine what we need to multiply what we would need to multiply